In this video and the next few after it, we're going to be talking about the Monty Hall problem and writing a program to go through it and do the simulation. So if you haven't heard of the Monty Hall problem, there's a whole lot of resources for it online, or you could listen to my explanation of it. The Monty Hall problem is a game show strategy. Let's say there are 3 doors. You're a contestant on a game show and there are 3 doors you can pick. One of the doors has a prize behind it. The other 2 have something useless, like, let's say buckets of mud. Buckets of mud versus $1,000 cash prize. So, let's say you pick one of the doors. The leader of the game show, the host, would then open one of the other doors and show you a bucket of mud. At this point, you have the choice. Should you switch to the other door, or should you keep your door? Well, it turns out, mathematically, you should switch to the other door. Which, that may sound kind of odd to most people, like, why would you switch? You have about the same chance either way, because it was 1 in 3. Well, the chance is greater that the prize is in the door that is still closed, the door that you have no idea what's behind. I'm sorry, the closed door that you don't currently have. Anyways, we're going to write a program, and it's going to simulate that however many times we say, probably about 10,000. But let's get started. First thing we're going to need to do is create some global variables to use as counters for this. So the first counter we're going to have is, let's make these all integers. We'll say keep door win sum. We'll have keep door lose sum. We'll have switch door win sum. So switch door win sum. And we'll have switch door lose sum. Alright, so what are these? All these are going to keep track of. We're going to run the program. Yeah, I'm pretty sure we're going to go with 10,000 times. We're going to keep the same door no matter what 10,000 times. And then we're always going to switch the door for 10,000 times, and we're going to see how often we win with each strategy. We made these global variables because we want any method to be able to edit any of these to count what's going on. So first we need to create some methods. Let's call this method public void. Let's actually public int, and we'll call it get prize door. Alright, so we create a method here, and it's going to return an integer, and that integer is going to be which door has the prize. So we need to, actually up here we need to import something to create a random number. So at the top we'll import java.util.star, so java.util.star. And then down here we'll generate a random number for the prize door. So we will say random rand equals new random, and int num equals rand dot next int, and we want to be number between 1 and 3. Oh, whoops, didn't need that. And we'll return num. Actually, we'll return prize door. We could call it num, but it's always good to name your variable something that's easy to keep track of. In this case, prize door is easy to keep track of because that's exactly what it is. Alright, so the user really doesn't know which door they're going to get, so let's create a method to get the user door. So we'll call it getUserDoor. So this method is also going to return an integer called userDoor. So random rand equals new random. Pretty much the same code as before, except we'll change the word to userDoor instead of prize door. So I'm just typing the same code right now. And we'll return userDoor. Okay. We're going to make the code in this video a little bit longer than it needs to be. Well, actually in this video and the next few. Then we'll probably have one video at the end where we actually go and cut down the code and get it as simple as possible, while still running through the Monty Hall problem. You'll realize at the end that the way to make it as simple as possible is just cutting back and pretty much generating random numbers from 1 through 3 and using those numbers for the answer. But we won't cut it back that far. For now, let's figure out how to figure out which show the host opens. Sorry, figure out which door the host opens. Alright, so we need to figure out what door the host opens. We'll say public int will return the door as a 1, 2, or 3. We'll call it host opens door for this method. And then we actually do need to take in some variables here. We need to take in the integer prize door. And we also need to take in the user door. And we'll put a little comment down here. Alright, so the host will never open the prize door. So if prize door will equal 1, 2, or 3. So if prize door is equal to 1, we have 3 different things that the user door could be. So inside this if statement, we'll say if user door equals 1, we need to randomly open one of the doors 1 or 2. So we'll say rand equals new random int host open, we'll just call it int open door equals rand dot next int, and then we'll say next int 2 plus 1. So that will give us a random number 1 or 2. And then we will return open door. But we're getting an error here because there's a whole lot of other combinations it could be. So user door equals 1 for a comment there. But let's say the user door equals 2. Actually, I'm sorry, there's a slight error here. I should have a 2 there. So this will randomly pick a number either 2 or 3. So if the user door is equal to 2, I cannot open the prize door 1. I cannot reveal the prize door. I can't reveal the user door, so that would mean I would have to return 3. Because I would then be forced to open door number 3. So it's gonna be, so if the user door is equal to 3, well, I can't ever open door number 1 because I can't show the prize. Can't open the user's door, so we'll say return 2. So we'll put a comment here, prize door equals 1. There's a few different combinations we could have. What if the prize door equals 2? Prize door equals 2. Well, we can have user door equal 1. So user door equals 1. Alright, so the prize door is 2, the user door is 1. We would have to return 3, because that's the door we want to open in that case. If user door equals 2, we need to pick a random number between 1 and 2. Rand equals new random int open door equals rand.next int, and we'll say 2 there, because we're picking a random number. Wait, hold on. Yeah, so here we need to open either door number 1 or door number 2. We'll say +1 there. So this will create a number 1 or 2. So if open door equals 1, return, let's see. Sorry if the logic's getting kind of confusing here, it's really hard to avoid this. So the prize door is equal to 2, the user door is equal to 2. So we want it equal, open door is 1 or 3. So we'll return 1 in this case. And then, let's see, if open door is, which is the variable we just created, is not equal to 1, it would be equal to 2, so open door equals 2. And I could have just put a not equal 1, or I could have just done an else here. All of them are going to do the same thing. Return 3. So in this case, we're opening door number 3. I think I'm out of time on this video. Well, there will be a part 2, and probably a few more parts after that. Thanks for watching.